So in this section, we continue chapter 3. We continue with the if selection statement. So in our first example, we'll convert these two lines of pseudocode into equivalent C code. And the purpose of this very simple algorithm is to look at a student's grade, determine whether it is greater than or equal to 60, and if the grade is greater than or equal to 60, it'll print the string passed to screen. If the statement is true, this line will be printed, otherwise not. The program will skip to the next line. So the equivalent code for that is this. So you can easily, you can imagine what the rest of this should be. We'll have a variable for grade, and all of this will be inside a main function, of course. But this is the conversion from pseudocode to C code. Like I said, it needs the definition of the variable grade and an assignment of a value to it first, but this is the heart of it. And as you can see, in addition to just two lines of code, the lines of code whose execution is conditional on the value of the condition being evaluated in the if selection statement. Those lines of code can be one, can be many. And if there are multiple ones, you have to put them inside a code of inside a block of code, and the start and the termination, the end of that that block of lines, of that block of code, is marked, denoted by these curly braces. So basically anything between this opening and this closing brace, curly brace, will be executed only if this condition evaluates to true. And the same thing in flowchart form looks like this. The if selection statement is represented by this diamond shape. If the condition evaluates to true, in this example, this statement, this block of this sequence of statements executes. If it turns out to be false, that block of statements is skipped, and you end up at the same point in the program as you would have if this condition was true and you had executed all the blocks in the if statement. All right. So not only, and we don't have to be strictly using comparison operations in the if condition. Actually, you can have absolutely any expression in there which can evaluate, which can be evaluated either to a 0 or a non-zero. And like I said before, the non-zero will be treated as true. The 0 will be treated as false. All right. Now, one step up from that is this example over here, this algorithm. It's slightly bigger, and what we want to do here is if the student's grade is greater than or equal to 60, we want to print the message passed. But in the other case, that the grade is not greater than or equal to 60, we want to print the message failed. So we want to print either passed or failed, not both. So this is not something we can this is not something we would have otherwise accomplished with just the if statement. Well, actually, yeah, we could have, but it would have been very awkward. The way to do that is using something called the if-else selection statement, which is basically an if statement followed by a new statement with the keyword else. And again, just like the if block, the else block can also have multiple instructions, multiple lines of code. And so in this case, either the block of code up here executes, or if not, then this block of code executes. But one of the two blocks of codes does execute, one or the other. And we accomplished that using this if-else selection statement. So let me show you the corresponding C code for that. So the if block looks the same as in the previous example, but that is now followed by a matching else block. Else, curly braces. As you can see, there's no conditional statement required, because either this statement, at this condition evaluated for the if statement, either that is true or false. If this is true, this executes. If not, it means it's false. Nothing else needs to be evaluated, and everything in here will be executed. The corresponding flowchart for this looks like this. So there are some statements that will be executed if the condition evaluated with the if statement, if that is true, and another set of statements will be executed if that condition turns out to be false. Now as you can see, this takes at least 4 lines of code the way we've seen it. There's a shorter notation for the if-else selection statement. So you'll use it quite frequently. So there's a shorter hand notation for it that allows us to do the same thing that an if-else block does on a single line. And for that, we use something called the conditional operator. This looks like a little strange, that the question mark followed by a colon. Here's an example. If we wanted to do the same example where we want to print either passed or failed using the selection statement, this is what that would look like. So over here, so inside the puts function, we have 3 parts to the selection operator. There's a part before the question mark. This is like the condition. This is the conditional statement following the if the if keyword. And this one again will either evaluate to true or false. If true, this will be executed. So whatever you have after the question mark and before the colon. If this condition turns out to be false, then whatever you have after the colon, that is executed. Another way to do this outside of the puts function, another way to do that is here, like this. You can simply put the statement over here, and you can put a complete statement between the question mark and the colon, and you can put a separate statement between the colon and the semicolon marking the end of the selection operator. And this will do the exact same thing. So whichever you prefer. Now, in addition to simply using the if-else statement one after another, we can also nest if-else statements, meaning we can put a pair of if-else statements inside either the block of the if or the block of the else keyword. So let's let me show you an example that further extends what we've been doing. So let's say now we want to write some code. What it does is this: it looks at the grade of a student, and depending on what range that grade falls in, this program should print out a statement that tells what letter grade the student was assigned. So for example, if a student has 90% or more as a grade, it should print that student got letter grade A. If a student got somewhere got 80 or more, he'll get a B grade. Between 70 and 80, a C grade, and between 60 and 70, a D grade, and for under 60, an F grade. So one way to accomplish that using the if-else selection statement that we've seen is this. This is one way to do it, pseudocode. Okay, so if the student's grade is greater than or equal to 90, print A. If not, we will jump into the else block, starting here. And inside the else block, we have another if statement, checking if the student's grade is greater than or equal to 80, and if it is, print B. But if not, we'll jump into the else block that is paired with this second if statement, which itself is inside this else of the first if statement. So basically, we have these pairs of if and else statements, and each if is inside the else of the previous if-else selection statements. You can see this looks kind of weird. I mean, this will work. We could convert this as it is into code, and it'll work. You can have an if-else block, and inside the else block you can have another if-else block, and inside the nested else block you can have another if-else block, and sure, that'll work. You can see that your code is getting indented more and more as you go inside. So this, sure, it's correct, but can make it a little difficult to read and understand. So the corresponding code would look like this. Nothing wrong with it. I mean, it'll function. It'll work. But in addition to the if and the else block, C also provides us something called an else if block. As you can see, if you write your code, if you want, this is what you want to accomplish. If you, instead of nesting if else blocks inside higher level else if or else block codes, you can write the same code like this. Let me explain how this would execute. So, for example, we have a student who has grade equal to 91. So we'll hit the first if block. This will turn out to be true, which means we go inside the if block, execute this line, and because we have entered this if block, next we'll jump to after the last else block that we have over here. Fine. But let's say grade for a student for another student is 71. What will happen for this student will be slightly different. We try to evaluate the first if statement. It'll be false. We skip over that block. We jump to the first else if block. We check if grade is greater than or equal to 80. No, it's not. So we jump over the code, over the block of statements of the first else if block. We hit the second else if block. We check if the grade is greater than or equal to 70. Yes, it is. We enter this block of code, execute the statements we find in there, and after we're done, we exit to the line after the else block. We do not evaluate this condition because this would also be true, right? If a student has a grade of 71, that same grade would also be greater than or equal to 60. Now, if you know that the student will get a C, in our case, it wouldn't make much sense to then also print D. So just to explain, so this is how this works. Once you enter into any one of the code blocks associated with either the if or else if blocks or else block, well, actually the else block is the last one. If you enter any of those code blocks, you execute those code blocks and you jump out to the line of code after the else statements code block. So as far as the C compiler is concerned, both forms, so meaning else if or else and inside of it if, they're both the same. They'll both do the same thing. All right. Should also clarify that it's not necessary that any of these code blocks of the if condition or the else condition or the else if condition, that they contain only a single line of code like we have seen so far. As a matter of fact, you can have any number of statements inside each of those blocks. So over here, the if block, the if condition has a code block of only one line. The else block on the other has multiple lines, 2. And that's perfectly fine. All right. So yeah, that's it for the moment, and I'll show you some hands-on examples now.